Okay, so now we're going to talk about something called percent composition, which is actually one of the easier things we do, but people have a tendency to just forget it, and so try to remember how it's done. It's not that hard. What it is it's a breakdown of the compound in percent, but the important thing is by mass of each element in the compound. Okay, so it's a percentage, but it's a percentage by mass of each element that's present in the compound. So what you're going to do is take the mass of each element, divide by the molar mass of the compound, and multiply by 100. So the biggest thing to do is make sure you have the correct formula before you start this, and you can also check to make sure your percentages add to 100 or very close to it. So sample problem, calculate the percent composition of CO2. So the way I'm going to do is I'm going to find the mass of carbon over the mass of CO2 times 100. So carbon weighs 12. CO2 is 12 plus 16 times 2 is 44 times 100 is 27.3 or 27% carbon. Now to find the oxygen, there's two ways to do it. Since the percentages add to 100, I would expect it to be 73% oxygen. Or, I'm going to erase the ink, I could say, all right, 12 plus 16 times 2, the mass of oxygen over the mass of CO2 times 100 is going to be 32 over 44 times 100. And when I do that, I get 72.7. Guess what? 73% oxygen. So either way you do it, if there's only two elements that you know they add to 100, it gets a little more complicated when they're a little bit bigger. So let me erase this ink. Okay, so I'm going to add this guy up. Nitrogen is 2 times 14. Hydrogen is 8 times 1. Chromium, if I look that up in the periodic is 52, but there's 2 times 52. And oxygen, 7 times 16. The total is 252. Okay? So to do the percent of nitrogen, I'm going to do 28, this number, divided by 252 times 100. The percent of hydrogen, I'm going to do 8 over 252 times 100. The percent of chromium, I'm going to do 104 over 252 times 100. And the percent of oxygen, again, I could do 7 times 16, 112 over 252 times 100, or I could just take everybody else and subtract it from 100. But it's just as easy to do this. So this is 11.1%. Hydrogen never contributes a whole lot. 3.2%. 41.3%. And 44.4%. Now if you add that up, it may not add up to 100. It might add up to 99.9 or 100.1. That's okay, because it's a rounding thing. It depends on how you round stuff. I am not going to overly be concerned about sig figs here. Okay, so no sig figs. As long as you don't give me every number your calculator spits at you. Okay, let me erase the ink again. Aluminum acetate, in order to do this one properly, first of all, you have to drop and swap charges. Guess what? That hasn't gone away. So aluminum is Al, acetate is C2H3O2. When I drop and swap charges, I get a 3 here. So the molar mass of this guy, and I'm not going to write it out, is 204. So the percent for aluminum is going to be 27 over 204 times 100. The percent for carbon is going to be 72 over 204 times 100. The percent for hydrogen is going to be 9 over 204 times 100. And the percent for oxygen is going to be 6 times 16. I don't know what that is. 96? 96 over 204 times 100. And I'm not going to do this because I'm sure you guys can handle this. It's not that hard. It's very similar to kind of scores on tests. The idea is, this is how much you got here, this is how many you got here, how many you got here, how many you got here. It's literally how much out of each, and I'm not going to do the next one.